Okay, first up, let's just call this a function of x. Let's list the candidate rational roots and kind of looking through it, the factors of 6 divided by the factors of 1. I want to point out what I mean by this. It's basically trial and error, and that's the factor 1. Let me get my eraser out, and what I'm going to do is I'm going to write down the candidate rational roots. And what are they going to be? Plus or minus. Well, the factors of 6 are 1, 2, 3, and 6. And the factors of 1, so those factors, pretty easy to write down now. It's going to be 1, 2, 3, and 6. Now that's 8 candidates. What I'm going to do is just, look for an easy one. And certainly looking at it and getting a little better at the arithmetic department over here and looking at it, I'm going to say 1 does not look like a good candidate. If you just plug in, you're definitely not going to get 0. But let's try minus 1. All right? What do you get over there? Well, you're going to get 1 plus 1 plus 6 minus 14 plus 6. That gives you 0. All right, 1 plus 1 plus 6 is 14. 14 minus 14 is 0. So what I want to do is, if that is a root, I know a factor of this, and the factor would be x plus 1. What am I going to do now? Long division to find out the remaining polynomial, which would be cubic. It's going to be doable. So let's write this over here, and I'll have a remainder of 0. X plus 1 divided into, and it's going to be very simple to do. It's x4 minus x cubed plus 6x squared plus 14x plus 6. All right, what do you get over there? Well, it looks like x cubed, x4 plus x cubed. This gives me minus 2x cubed. I'm going to drop all the places down. Match it. That's going to be minus 2x squared. What do you get there? Minus 2x cubed minus 2x squared. Subtract. And now what do you do? Plus 8x. What do you get there? 6x plus 6. What do you get there? Plus 6 now, which would give you 6x plus 6. So I know the other factor now, and it's a cubic. It's x cubed minus 2x squared plus 8x plus 6. All right? So someone's going to say, what are you going to do now? You can continue. Right, I'm going to erase this over here. This is done. My division's done. That's a remainder of 0, by the way. Erase this over here. And, it is factored, by the way. I'm not saying it's completely factored, but it is factored. Just like the last problem we didn't go beyond the first step. But looking at this thing over here, you might say, could you do that? Well, if it does have, a rational root, it still has to come from this list, all right? This might be easier to look at, though. And what I mean by that, you could try, minus 1 again if you want. Let's put that down. What would you get? Well, you'd get minus 1. I'm using it in the second factor now. Minus 2, minus 8, plus 6. There's no way that's going to give you 0. You could try 1. No, we already tried 1. We wouldn't try that again. By the way, you could try minus 1 more than once. It could be a repeated root, all right? But then you go through the list, 2, minus 2. Let's try minus 2. What do you get? You get minus 8. That's not going to work either. Let's try 2. You get 8. Then you're going to get minus 8 plus 16 plus 6. You get the idea. Not working out, all right? So I'm going to say, we got one of the factors. We're pretty happy about that, just like we did before. We got one of the factors. All right, let's look at the key. And as I do that, I want to point out in the key, they list the potential roots. We did that before. Trying, and I do mean that, this is really trial and error using a rational root theorem. What we found out was x equals minus 1 is a root of the problem, which means that x plus 1 is a factor of the polynomial, and then we use long division to get this over here. Did we get the same result? We got the x plus 1. We got the x cubed minus 2x squared plus 8x plus 6. Thank you.